in chapter 7 with our ratios and our scale factors, stuff like that. So we're kind of coming back to that today. So a dilation is a transformation. That changes the size of a figure. Okay, so we still have this transformation just like we had our other transformations before. So in a dilation, the figure can be enlarged or reduced. Therefore, a dilation is an enlargement or a reduction. Okay, so we can either state that it is an enlargement from your pre-image to your image, so it gets bigger, or it is a reduction, so from your pre-image to your image, it's getting smaller. Okay? Now, I do want to list out our different transformations. Oops, that's an R. Okay, transformations. So we have 5. What's one of our transformations? Translate. To translate? Okay, so translation is one transformation. What's another one? Rotation. Rotation. What's the other one? Reflection. So those are the 3 that we started with. Okay, so we started with reflections, went to translations, and then rotations. That's what your quiz was on. Okay, the next one that we went over was kind of this combination of transformations. Do you remember a specific combination of transformations that we went over? What that specific name was called? A glide reflection. Okay, so that's when we did a translation and then a reflection. Okay, so that is still a specific kind of transformation. It's a glide reflection. Okay, the last one is the one we're talking about today. That is a dilation. It is still a transformation. Okay, so these are our 5 transformations that we've talked about in this chapter. Now, with our first 4 transformations, these were isometries. Do you think a dilation is an isometry? No, it's not. Okay, so your dilation is not an isometry. The other 4 are. Do you remember why the other 4 are isometries and this one is not? Alexis? Because their shape and size stay the same. For a dilation, we're changing the size of this figure. Okay, so we're changing the size of the figure. That is why a dilation is not an isometry. Okay, so the new figure may be smaller or larger than the original by a scale factor. Okay, so we have this scale factor that we can multiply into our figure to make it larger or smaller. So the new figure and the original are similar. Okay, remember in our chapter on similarity, we did do dilations. Okay, so they have the same shape, but not the same size. Okay, so dilations are completed with respect to a center point and a scale factor. So for your dilation, it's going to be from a certain center point, and it's going to get larger or get smaller closer to that center point. Okay, so it's with respect to that center point and the scale factor. So if our point P at xy is the preimage of a dilation centered at the origin with a scale factor of r, then the image for P prime is r times x and r times y. So all we have to do is take our scale factor of r and multiply that value into both x and y in our coordinate to get our image. Now, we also are able to find our scale factor. Okay, so for our scale factor, we're going to take our image length over our pre-image length. Okay, your image is that prime coordinate. Okay, so in our example above, P prime would be your image, and your pre-image would be P. Okay, so you take your prime over your not prime, your original, to find that scale factor. So we're going to do some examples of this. So we want to state whether the dilation from B to B prime is an enlargement or a reduction. Then find the scale factor of the dilation. Now, for this first example here, notice these are both B. Okay, it's not labeled prime. Okay, that was a misprint. This one right here is supposed to be B prime. So label that one as B prime. So that means in our picture here, this one off to the right is your pre-image. And this one right here is your image. So if I'm going from this shape, this triangle, to this triangle, is that getting larger or smaller? It's getting smaller, closer to this center point right here. Okay, so since it's getting smaller, this should be a reduction. Okay, so it's getting smaller, so it is a reduction. Now, it is getting smaller towards this center point. So your dilation has to be around a center point. That's this point right here. So to find your scale factor, you need to use that center. You need to figure out your length from the center to your image. Okay, so from this center to your image is 4 units. Okay, so to find my scale factor, I need that prime coordinate. Okay, that's 4 units. Okay, then I need my original length from my center to a point on that original. So I need that entire length there. So I need 4 and 6. That's 10. Okay, it's not just 6. Okay, that's your length from your image to your pre-image. I need the length from that center to my pre-image. Okay, so that would be 10. And I can reduce this to 2 over 5. Okay, and since this is a reduction, that fraction should be less than 1. Okay, so 2/5 is less than 1. So that shows it is getting smaller. Questions? All right, do example 2. That one should be labeled, yeah. Okay, do example 2. All right, so what type of dilation is this? It is an enlargement. Okay, so this one is getting bigger from your pre-image to your image. Okay, so here Q is your image, or your pre-image, sorry. And Q prime is your image. Okay, so from our pre-image to our image, it got larger. So now what I want to do is find the scale factor. So first I need the distance from that center point C to our image. Okay, so that length of our image here will be 15. That's over our pre-image length from the center to our point Q here. That's 5. Okay, 15 over 5 is the same as 3 over 1. So our scale factor would be 3 to 1 by reducing that fraction. Okay, any questions on finding the scale factor? All right, then the next section here. This time we're going to be given a scale factor and we're going to have to actually plot our dilation on a graph. So to find the coordinates of an image after a dilation centered at the origin, multiply the x and y coordinates of each point on the pre-image by the scale factor of the dilation r. So this is our rule here. So we take our original xy coordinate and we multiply r into x and r into y. Okay, so you're just taking that scale factor and multiplying each of your coordinates. So in the examples below, we want to graph the image of each polygon with the given vertices after a dilation centered at the origin with the given scale factor. So in number 1, we have points E, F, G, and H. And this R value here is our scale factor of 0.5 or 1/2. Okay, so I want to plot my pre-image first. So plot out points E, F, G, and H. So point E is at -2, -2. Point F is at -2, 4. G is at 2, 4. And H is at 2, -2. Okay, so here is my pre-image. Okay, next I want my image, and to find my image, all I have to do is multiply that 0.5 into both x and y for each of my coordinates. Okay, so for point E there, I want to multiply -2 by 0.5. Okay, so multiply -2 by 0.5, and again, -2 times 0.5. So I'm just multiplying r into each of those values. Okay, when I do that, I should get -1, -1 as my image coordinate. Same thing for f prime. Multiply 0.5 into -2. That's -1. Multiply 0.5 into 4. That's 2. For G, multiply 0.5 into 2 and 0.5 into 4. Last one, H, 0.5 times 2, again is 1. 0.5 times -2 is -1. Okay, so after I find each of those coordinates, I can just plot them on my graph. So I have -1, -1. That point is E prime. I have -1, +2. That's F prime. +1, +2 is G prime. And 1, -1 is H prime. Okay, and you can see that it did get smaller. So our scale factor was less than 1. So our figure should get smaller and closer to the origin. Okay, since this is centered around the origin. Okay, so it should be getting closer to the origin if it is less than 1. It should be further away from the origin if it is greater than 1. And it should get larger then as well. Okay, questions on number 1. All right, I want you guys to do number 2 then. Okay, so number 2. Not done yet. No. What? Is the gray sheet that was due yesterday? What? All right, so number 2, you should have A prime at -4, -4, B prime at -2, 4, and C prime at 4, 2. And your image, this outside one, should be larger than your pre-image. Okay, and our scale factor was 2. It's greater than 1, so it should be getting larger. And it is expanding away from the origin then. Okay. Any questions?